Hey guys, Greaves here. Let's go over review 19. Okay, review 19. This question is a short, free response, right? Show your work. Okay, so what do we got here? An object is released from rest above the Earth's surface at a height h, as shown in the diagram. Okay? Determine whether the system containing only the object is open or closed with regard to the mechanical energy of the system. Okay, so is it open or closed for just the object? All right, well, let's see. I let go of the object, right? And what happens? Well, first of all, an object can only have, hopefully we remember, an object can only have one type of energy, and that is kinetic energy. And right now, if it's just the object and I let it go from rest, right, the kinetic energy of the object is 0. But we do know that if I let go of an object near the surface of the Earth, the object is going to accelerate downward, meaning that its velocity is going to increase, meaning that its kinetic energy is going to increase. So, is the object open or closed? Well, for just an object, it is most definitely open. Why is that? Because the mechanical energy of the system is going to increase. So let's just say Y energy of my system increases. Okay? Open, right? It's going to fall to the earth, right? It has 0 energy. Before it hits the ground, it has kinetic energy. Energy is going into the system. Okay, that's that guy. Determine whether the system containing only the object and the earth is open or closed with regards to mechanical energy. Okay, now that I have the object and the earth, right, I can include, right, potential energy. Potential energy is a consequence of more than one object in the system, right? So, what do we got here? This is definitely closed, right? It's a closed system, right? Why is that? Because the object has potential energy when it's up high, and we know that for a closed system, the kinetic potential energy, well, I should say in this particular case, the potential energy here, right, is going to be converted to kinetic energy down at the bottom. So this is a closed system. Some reasoning, right, because the potential energy here has to be equal to the kinetic energy at the bottom. Okay, so that is a closed system for that guy. What's next? All right, determine whether the total momentum of the object Earth system, right, increases, decreases, or remains, increases, or system increases, decreases, or stays the same, right? Also determine whether the kinetic energy of the object increases, decreases, or stays the same as the object falls to the center of the Earth. All right, so they're asking for two things, right? All right, what happens to momentum? Well, in a closed, isolated system, the momentum is always conserved, which means it is the same. So hopefully we are saying that it is the same, right? So the momentum is the same. Also determine whether the kinetic energy of the object increases. Well, I know that I'm letting the object go from rest, right? As it falls, right, its kinetic energy is going to increase, right? So in a clear, coherent paragraph, right, determine why. I mean, you know, well, U is equal to K. There's many different ways that you can describe that as well. Okay, so so for B, what do we got? Momentum, closed system is the same, you know, it's the same. And what about kinetic energy? That's going to increase. Okay, so that is 19.